Kia ora koutou. This is the second video on last year's Dubsy Year 11 exam. I'm going to do two harder problems involving parabolas in this one. So the first question we're going to look at continues on from the video I did earlier today, where we had to find the equation of this graph. Now we found, and in vertex form, we found that it was y equals negative x minus 3 squared plus 3, and we can also write that in expanded form as y is equal to negative x squared minus 6x plus 9 plus 3, and then expanding out all those brackets we get negative x squared plus 6x minus 9 plus 3, which gives me negative x squared plus 6x minus 6. Now that makes sense because you can see that my y-intercept is at negative 6. The negative sign makes sense because it's an upside down parabola, and this stuff here fits in with the vertex being at 3, 3. Okay, so that was in the last video. Now what we're asked to do here is a little bit harder. We're asked to find the equation, or the formula, but the equation of the new graph after it's been shifted 2 units down and then reflected on the x-axis. So let's first of all talk about how we shift up and down. And if we want to shift down by k units, it's really, really easy. All we have to do is take my function, whatever it is, and we're going to go minus k. Let's just think with a table about why that's working. Suppose we go back to x here, and we'll just do our basic parabola, y equals x squared. So x squared is 0, 1, 4, and 9, and so on. And we could put in some negative values like that. Now, if I now do the equation of x squared minus 5, you can see that that y value goes to negative 9, this one goes to negative 4, this one goes to negative 5, and so on. So each of these y values is 5 lower than the old one. And so what we've got on the graph is that if we had a point here, taking 5 off it drops it down by 5. So we have a parabola that's been shifted down. And that will work if it's a parabola or a cubic or an exponential or anything. So a vertical shift, we just put minus k to shift down and we put plus k to shift up. And that means that the first part of this question is really, really easy, right? Because we want to shift this down first. So we can take either one of our equations. We can take this version of it here, or we can take this version of it here, and we're just going to put minus 2 on the end. So to shift it down, where's my nice fountain pen gone? Let's see. We'll do it with both. We get y equals negative x minus 3 squared plus 3, and then we take away 2. That gives me negative x minus 3 squared plus 1. Or we can take it off here. We get negative x squared plus 6x minus 6 minus 2 to shift it down, which gives me negative x squared plus 6x minus 8. Okay, so that's one way to write it, and that's the other way to write it. Now at the end I'll show you all of this in GeoGebra. The next part of the question asks us to reflect that in the x-axis. So we're going to shift it down, get that equation, and then we're going to reflect it. So let's have a look at how we do a reflection. Suppose that I've got, let's use y equals x squared again. If I want to reflect that, then this point here, suppose this point was, let's see, let's make it 3. I'm just making up numbers here. Let's make it 3 and 4, which means, of course, that that equation is not y equals x squared. Well, what do I want that new point value to be when I reflect it? Well, just looking at it, the x value stays the same, but the y value will be negative 4, right? If I have this point here, suppose that point is 1, 0.5, then when I reflect it, it will be 1, negative 0.5. So in general, what we're going to do to reflect in the x-axis, if we start with y equals blah, 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 then the reflection will be y equals negative blah, blah, blah. And it really is that simple. And again, this will work on all patterns, not just quadratics and not just linear ones, any function or any curve. So here we started off with y equals negative x squared plus 6x minus 6. Then we dropped it by 2. So we got negative x squared plus 6x minus 8. And this is the one that we want to reflect. And so the new one will be y is equal to the negative of all of that, which gives me x squared minus 6x plus 8. Now let's have a look using GeoGebra at what that looks like. Here we go. Okay, so the first graph that we've got, this one here, is y equals negative x minus 3 squared. No, it's not. That's the second one. That's after it's been shifted down. The first one is this one here, y equals negative x minus 3 squared plus 3. And then the blue one is this one reflected in the x-axis. And so that's going to be equal to negative of this, which works out to be x minus 3 squared minus 1. And we could write that in expanded form as x squared minus 6x plus 9 minus 1, which is x squared minus 6x plus 8, which is what I got over the page. All right, now I've just got time to do this next one, which is an in-context problem about a tennis ball. So the hardest thing with these sometimes is to work out what you're being asked, and then we need to go and choose which one of the 3 parabola equations is going to help me the most. But usually what we have to do is to find the equation of the curve and then solve something to do with it. So the path of the tennis ball can be modelled by this graph. When it passed over the net, the ball was at a height of 3.2 metres. So here's 3.2 metres here, and the height was decreasing. So that means that the tennis net is here, right, when the height is 3.2, and we're on the going down side of the parabola. So how many seconds after it hit did the ball pass over the net? What we're looking for is what is that x value there. So the steps here are to find the equation, and then step 2 is to solve 3.2 equals blah, blah, blah. Okay, I'm going to work here with y and x. Sometimes we'll work with t and h, but for today I'll work with y and x. So let's take a look. We can see the vertex. We don't know anything about this, and we don't know where this is here. So we're not going to use intercept form. We're going to straight away decide that we will use vertex form. So vertex form here will look like this. The vertex is at 1.25, 4.325. That means that the equation is going to have this pattern. Y is equal to some scale factor times this plus 4.325. And if you're watching this video confidently, you should be feeling pretty good about basic vertex form now. It's just got slightly yuckier numbers. So now we have to work out the scale factor to see like how stretchy my parabola is. We know where the vertex is. It's at 1.25, 4.325. So the only other information that I've got that I can use is this point here, which is the y-intercept. We know that the y-intercept is on the curve, so it has to satisfy that equation. So substituting in, it looks gross, but we get some quite nice numbers in the end. We get 1.2 is equal to a times 0 minus 1.25 squared plus 4.325. Cleaning that up, I get 1.2 is equal to a times 1.5625. Don't round that number. So doing a little bit more I guess we're really doing Year 9 algebra now, so it's 1.2 minus 4.325 is equal to 1.5625 times A. This gives me on the left-hand side negative 3.125 is equal to 1.5625A. Dividing that by that gives me negative 2. Now that means that y is equal to negative 2 times x minus 1.25 squared plus 4.325. I can expand that out, but I don't have to. So what we have to ask now is when is y equal to 3.2? Let's look at what we're doing on the graph, right? We've got the equation, and we're saying we want to know when did the ball pass over the net. So the ball was at a height of 3.2, and it was on the decreasing side. So we're over here, and we're figuring out the time. So when is y 3.2? Substitute in and solve again. So 3.2 is equal to negative 2 times x minus 1.25 squared plus 4.325. Negative 1.125 is equal to negative 2 times x minus 1.25 squared. That gives me 0.5625. All I'm doing here is I'm just dividing both sides through by negative 2 is equal to x minus 1.25 squared. Now I can take the square root of both sides at this point, but I have to remember that I could be dealing with either the positive or negative version of that square root. So that's square rooting both sides. So the square root of that number is a very nice 0.75. So this is what we've got here. We've got x minus 1.25 equals this. That gives me x is equal to 1.25 plus or minus 0.75, giving me two values for time. X is equal to 2 or x is equal to 0.5. Now let's go back and look on the graph and see what that's all about. And it will make perfect sense in a minute. Let me clean our graph up a wee bit. Okay, so we can see that what we've done is we've said when the height is 3.2, we've got two possible values for the time, 2 and 0.5, and that fits the graph perfectly, but we know that we want the one when the height is decreasing, so that's this one over here. So the answer to the problem is after 2 seconds. So there you go. It's obviously much more involved than some of the basic skills problems, but once you have a good grip on the 3 forms of a parabola, then the main things you've got to be confident with doing are substituting and solving equations using the skills that we built on this year that we first saw in Year 9 and 10. Thanks for watching, and email me if you've got any other questions you'd like me to do.